Kubernetes Pod Scheduling, Balancing Cost and Resilience. Today, we're diving into a crucial aspect of Kubernetes that directly impacts both your infrastructure costs and application reliability: pod scheduling. We'll explore how to strike the right balance between cost efficiency and system resilience, and how you can fine-tune Kubernetes to get the best of both worlds. Whether you're running a startup app or managing a large-scale enterprise cluster, this video is for you. What is Kubernetes Pod Scheduling? At its core, Kubernetes Pod Scheduling is the process of deciding which node in your cluster will run a specific pod. The scheduler makes this decision based on available resources, rules, and constraints. But here's the catch. If not configured properly, it can lead to either underutilized resources or poor fault tolerance. Why scheduling matters for cost and resilience. Pod scheduling isn't just a technical step, it's a strategic lever. Cost efficiency. You want to use the fewest resources necessary without wasting compute power. Resilience. You want your applications to survive node failures and traffic spikes. The problem? These goals often compete. Key concepts in pod scheduling. To balance cost and resilience, you need to master a few Kubernetes scheduling tools. Node Affinity and anti-affinity use affinity rules to control where pods run. E.g., place all pods on nodes with SSDs or spread out replicas to different zones for resilience. Taints and Tolerations. Use taints to repel general workloads from critical nodes, and tolerations to allow only specific pods. Resource requests and limits. Always define resources.requests and limits to help the scheduler place pods based on actual needs. Priority classes. Assign higher priority to critical workloads, so they're scheduled first or rescheduled faster in times of resource crunch. Pod topology spread constraints. Enforce rules to spread pods across zones, regions, or nodes, improving fault tolerance. Cost optimization strategies. Let's talk money. How can we reduce cloud bills without sacrificing performance? Use spot instances plus tolerations. Run non-critical workloads on spot preemptible nodes using taints and tolerations. Autoscaling. Use cluster, Autoscaler, and horizontal pod. Autoscaler HPM to scale based on demand. Bin packing schedule multiple small pods on the same node to maximize utilization. Improving resilience. Now let's ensure your app survives real-world failures. Use multiple availability zones. Always schedule replicas across zones. This avoids single point of failure. Pod disruption budgets, PDBs, prevent too many pods from going down during voluntary disruptions like upgrades. Readiness and liveness. Probes don't route traffic to failing pods. Use probes to ensure only healthy pods get traffic. Schedule free meeting at Kubeify.com today.